All right, we're going to look at functions and function notation. And so what we have to understand about functions, they have two major components that we need to look at is inputs and outputs. Okay, so you see this function notation where you get f of x equals x plus 10. You might see something like that. Okay, so the x is equal to the input, and the f of x is the output. Okay, so this is the thing you put into the equation. This is what you get out of the equation. So if I was to say something like x equals 4, and I was using this function, I would do f of 4, that's how you say it, of, equals 4 plus 10. Right? And then I work that out, and this is just notation to tell me f of 4 equals 14. So this was my input, and the 14 is my output. Okay, so let's just go ahead and do a few inputs and outputs here. So I'm going to give you f of x equals the absolute value of x, and we're going to figure out what is f of 8. Okay, so what that's telling me is that the input was 8, so I'm going to put an 8 in there. And what is the absolute value of 8? Right, and that is just 8. Right, so my in was an 8, and my out was an 8. In that case, it turned out to be the same, right? So, but what if I said, okay, same question, right? I'm still using this f of x equals the absolute value. What if I asked you, what is f of negative 4? Okay, so now I'm going to put a negative 4 in there. Okay, and absolute value is asking me how far we are from 0. So f of negative 4 is positive 4. So in this case, my in was negative 4, and my out was positive 4. Okay, so let's do some different functions now. We'll use g of x this time. Okay, separating this is a different question. G of x equals 3 to the x plus 1. And what we're going to do is we're going to find out what is g of x when x equals 2. So what we're really trying to figure out is g of 2. So I put this into my input. All right. Now I got to follow order of operations here. It tells me exponents first. All right. And then I get 10. So this was my out, and 2 was my in. Inputs and outputs. All right, let's look at another one. What if I said f of k, just kind of changing the variables, equals k over 2 plus 1, and I want to know what is f of negative 6. Okay, so I'm going to go ahead and put that in my input. So it's going to be negative 6 over 2 plus 1. Follow the order of operations tells me to divide before I add, and then I get negative 2, right? And so what we get is an input of 6 and an output of negative 2. Okay. So this has got a lot of real life applications. Think about it when you go to if you go to In-N-Out, depending on what you order will affect the price, right? So if your input's a milkshake, your output could be a certain price, but if your input is a cheeseburger, your output is going to be different. So it changes. Okay. Let's look at something like this. If f of x equals the square root of x minus 5. So we'll do a couple for this one. Let's do f of x, or f of 30. Okay, so I'm going to go ahead and put that into the function. I'm going to get 30 minus 5. So I'm going to do inside the square root symbol, I get 25, and x equals 5. Right? So when my in is 30, my out is 5. Okay. So what if I did another one? What if I did f of 2, right? For the same function. So 2 minus 5. I'm going to do underneath the square root first, and that gives me -3. And if you remember, I cannot take the square root of a negative, so that is undefined. Okay, so if I put in a 2 as my input, it's not so much that my output is outdefined, as I'm going to say is there is no output. Okay, I cannot go to In-N-Out and ask them, all right, how much does a taco cost? They're not gonna say, well, $2. They're gonna say, no, we don't even offer tacos. It doesn't fit into the function.